for which of the following transitions would a hydrogen atom emit a photon with longest wavelength? And so now let's talk about what the hydrogen atom looks like. I'll draw a picture of it down here, and I'll put the nucleus, right here. And from the nucleus, we have, and I'll only draw them as sort of partial circles here, we have what's called the n equals 1 energy level. Then we have the n equals 2, n equals 3, n equals 4, n equals 5, n equals 6. And what I've tried to do here on its side is draw how the energy goes. So the energy difference between 1 and 2 is larger than the energy difference between 2 and 3. And so as you go, the energy levels get closer and closer together. Okay. 5, 6, and then you keep going all the way out, and I'll stop making them, but I'm going to draw them closer and closer together until you get to n equals infinity. And for n equals infinity, what that means is that the electron has left the atom. And we have an equation that allows us to calculate the energy change between energy states, and it goes like this. E equals minus 2.18 times 10 to the minus 18. And the equation is right here on your conversion and equation sheets. And the only thing I'm going to do is I'm going to put n final instead of n2, and I'm going to put n initial instead of n1. But otherwise, I'm going to just write this equation. Right there. Now, for this equation, you can, if you plug in numbers, and you can plug in all of these numbers to see what the different energy differences will be between these levels. And but what you will find is two things. First off, as an electron goes farther away from the nucleus, the atom must, or the atom itself, we can think of it as the atom or as the electron in the atom, must absorb energy. And as the electron comes towards the nucleus, the atom or the electron, or really both, must emit energy. And so, as we come up and look at our actual question, it says, for which of the following transitions would a hydrogen atom emit a photon with longest wavelength? Well, there's a lot to unpack here, but first off, if it's going to emit energy, it has to be going from higher n to lower n. Okay, so we have this option and this option as the only options that could be answers. Okay, and then we have to unpack this part about longest wavelength. So our understanding of energy comes from this equation. E equals hc over wavelength. And what this equation means, whether you remember it or whether you can use this equation, it means that as wavelength increases or as wavelength gets longer, that means this number in the denominator gets bigger, and so therefore the energy gets smaller. So this part of the question where it says longest wavelength means lowest energy. So we are now looking for amongst these two, which one is the lowest energy. And you're talking about either 3 to 2 or 6 to 7. And again, this is just a schematic, but it does represent the energy that you could calculate using this equation. And the smaller energy, or the lowest energy, will be the 7 to 6. So there's two ways to tackle this. One is to think of this picture. Another is to actually use this equation and plug in 6 and 7 and 3 and 2, and it will totally work. Anyway, I always like having multiple ways to solve problems, or to think about them, just in case either one works or sometimes both of them work. Any questions about this problem? Okay. And then we will stop. Let's see. No, we're still making pretty good